Intercepts, there are two important intercepts, two parts of any functions that are intercept, which means there are x-intercepts and the y-intercepts. Pretty sure you guys have come across this before. When the graph intersects your x-axis, that point of intersection of the graph with the x-axis is called the x-intercept. When the graph intersects the x-axis, so that point of intersection of the graph with the x-axis is called your x-intercept. On your x-axis, all the values of the y is 0. So the ordered pairs will be any value of x, comma, y is 0. When the graph intersects the y-axis, that point of intersection of the graph with the y-axis is called your y-intercept. On your y-axis, all the x values are 0. So the ordered pairs are going to be 0, comma, whatever the value of y is. Okay. So to find out the x and the y intercepts using the graph, you can look into this concept. But if you have to find the x and the y intercept from the given equation, you must plug in the opposite variable as a 0. If you are finding the x-intercept, you need to plug in the value of y as 0 and then solve for x to get its value. If you are finding the y-intercept, you must plug in the value of x as 0, then you solve for x to get its value. Okay. Now you want to identify the x and the y intercepts from this given graph. Now I observe that there is this point and this point that intersects on the x-axis. So our x-intercepts over here could be between 0 and 1. So 0.5, comma 0. There is one more on the other side between -2 and -3. So we can have -2.5, comma 0. There is one y-intercept also on the graph that we are able to trace it. That is over here. This is going to be your y-intercept. And that is 0, comma 1. Now, next we'll look into the domain and the range. So we want to recall that the domain is all the x values, and the range is set of all y values. Set or the set builder notation used to identify a finite set of points. You write it down like this is the set or the set builder notation. Interval notation used to identify an infinite number of points on the line or the curve. Interval notation could be in the curly brackets, in the brackets or the parentheses. Okay, there are 3 different graphs given to us, and we want to find out the domain and the range of each of these graphs. These are just the points, so we will first put down their ordered pairs. -3, -4. That is -1 and 3. 0, 1. 2. And 4, 4, 4. They are scattered points, so the domain are all the x values of these points. We have -3, -1, 0, 2, and 4. That is our domain of this given graph. The range. It's -4, 1, 3, and 4. 4 is repeated twice, so you just write it once as the range of this graph. There is a connection between the points and there is a direction of the graph. So in such kind of graph, if this is an open circle as a starting point, that point is not part of your graph, but it is a starting point of the graph. To find the domain of this, it is an interval from x equals to -3. Now, since this is an open circle, we put -3 in the parentheses, and it has the arrow, which means it goes all the way until infinity. And infinity, we always use parentheses, either -infinity or +infinity, always use parentheses for that. So this is your domain. Then the range. Go from down to up to find the range. Y is -2. Again, it is an open circle, so parentheses, and it is going all the way up towards infinity, positive infinity in the parentheses. Okay. And then the last graph, you have the arrows on both the sides, and it's a continuous graph. This represents that the domain is all real numbers that represented in the interval notation as -infinity to +infinity. And the range of this graph is, you can start rolling your pencil from down to up. The graph stops at that point. There is no graph beyond 4. So it starts from lower value, which is -infinity, and goes all the way to 4. 4 is included in your graph, so you should put a bracket at the 4. That is your range of this given graph. Now we'll work on this example to answer all of this. This is just a summary of what we have learned in this section. Looking at the graph, you are going to answer this. G of 2, which means when x is 2, what is the value of y? When x is 2, the value of y is 2. So G of 2 is 2. G of -3, when x is -3, what is the value of y? Technically, if it was a closed circle, then we would have had -2 as its value. But because it is an open circle, we say it is undefined. Find all x values for g of x equals to 0. Y is 0. Where is y 0? Y is always 0 when on the x-axis. So at that point, we are going to find that x value, which is between -2 and -3, so -2.5. Find all the x values when g of x, y value is 3. Y is 3. So at this point, x is also 3. There is no graph on the other side. The x-intercept of this graph is, of course, this one, -2.50. This is also your x-intercept. And the y-intercept is that value, which is 0, 2. And we just recently discovered the domain and the range of this graph. So the domain is x as -3 in the parentheses to infinity. And the range is from -2, y value as -2, the starting point of the graph, to positive infinity. And that completes our section. 2.1.